Well, what do you do if you don't have that kind of money? Jean was supposed to put $42,000 into a savings account to pay for his son's education in 18 years, but most people don't have $42,000 lying around. He may, and if he does, that's fantastic. But if not, what can he do? Well, you can use an annuity, which is an account where you make regular fixed deposits every month, and then the interest is compounded with the general compounding formula, and then you get money out when you're done. Now, the difference between an annuity and general compounding is that with an annuity, you're making a payment every single month. So with a general compounding, it's like Gene, he had $42,000 sitting around. He decided to put it into an account for his newborn son. And that's one lump sum at the beginning. This annuity is a small amount each month, essentially. So what I'm saying is that you deposit a fixed amount, the same amount every month, or every year, depending on how you decide to do it, and you end up with a very large amount of money. So if we want to use the annuities formula, this version of it is solved so that you can find a future value. And so you have to know your payment up front, and then you can find the future value of your account. Future value, that's the same as the ending amount. And the question, before I forget, the question that we can answer with this formula is, how much money will I have if I deposit a certain amount every month? And I'll say in T years, and that's the question we'll answer with an annuity formula. So the PMT, that's the payment amount, which is the same thing as a deposit. And then the R is still going to be our rate as a decimal. The N is still the number of compoundings. And the T is still the time in years. Now, this formula is going to look somewhat like our compound interest formula in terms of, you can see here we have the 1 plus R over N raised to the NT power. That's just like what we had before, but we are also dividing by R over N, subtracting 1 first, dividing by R over N, and then multiplying by the payment amount. And that's because we are not just taking a lump chunk and leaving it sit. We're continually adding to it with both interest, because it's a compounding situation, and our regular payment. So that's going in as well. So the two of those are why we need a different formula. So it is based on the general compounding formula, though.